All right, good morning, everyone. Welcome to the South Atlantic LCC's third Thursday web forum. I'm so excited to see this long participant list. We've got great attendance this morning. My name's Hillary Morris. I work on Blueprint User Support and Communications for your cooperative. I know most of you are familiar with the overall format of these calls, but for anyone who may be joining us for the first time, each month your cooperative hosts a web forum featuring a key presenter discussing current and ongoing work throughout the cooperative. So as the name implies, it takes place every third Thursday of the month at 10 a.m. and serves as a great chance for folks to ask questions and provide input to help guide the conservation future of the South Atlantic. So every web forum has roughly the same agenda. We'll first introduce our presenter, who will speak for about 30 to 40 minutes. And after that, we'll set aside a block of time to ask questions about the presentation. And whatever time's left will include updates from your cooperative, followed by an open discussion where anybody can ask questions about what the staff is up to. So before we get into the heart of the webinar, a few logistics. Hopefully most folks have muted themselves, but I'm hearing a little noise this morning. So I'm going to mute everybody during the presentation. So if you have any questions, you can type them directly into the chat box, and I'll monitor that. Or you can hold them until after the presentation. If you do use the chat box and want everyone to be able to read the question during the discussion, just remember to send the note to everyone rather than just an individual. And to speak at any point during the discussion session, all you need to do is press *6 to unmute yourself. Are there any questions or concerns or comments before I mute everybody? All right.
The conference is now in silent mode.
So on the line today from your cooperative staff, we have Ken McDermott. Rua Mordecai is actually traveling. He's in Louisiana right now. But we also have Amy Keister, Janet Shakir, Brad Pickens, Louise Vaughn, and me. So today presenting, we have Tom Allen with the East Carolina University Department of Geography and J.P. Walsh with the ECU Institute for Coastal Science and Policy and the University of North Carolina Coastal Studies Institute. And they may be joined by two of their other project co-leads, Jim Morris with the University of South Carolina Baruch Institute for Marine and Coastal Sciences, and Clark Alexander, who's with the University of Georgia Skidaway Institute of Oceanography. So those folks should also be available for questions. I'm going to pass presenter power over to you to get us started now, Tom. Don't forget to *6 to unmute.
Okay, how about this?
Beautiful.
Okay. A little quirky start there. This is an update on a project that's very integrative. J.P. Walsh is and Clark Alexander, two coastal geologists on the project with me. And Jim Morris is, of course, well-known coastal ecologist down at Baruch, and I'm a geographer, rather jack of all trades, remote sensing, GIS, coastal specialist here at ECU. The first part of our talk is going to be quite image processing, remote sensing oriented, the objective of mapping the high and low marshes. Then we're going to move into looking at the integration of field observations and doing things like LiDAR and Diem correction, and then finally Marsh vulnerability assessment. So each of these three thrusts is kind of led by different folks on the project. And the purpose really is to basically get beyond some of the ambiguity that exists in high and low marshes as they are mapped in the past, particularly by federal agencies, and basically to refine those maps, make them something that may be more practical for management purposes and for monitoring marsh condition and health. There are definitely dynamic concerns there, and this built out of a project I recently did with the Fish and Wildlife Service National Wetland Inventory Program, trying to apply new satellite sensors and classification techniques. So the second bullet here is really describing that particular issue of high and low marsh differentiation. And definitions are a pretty important aspect of that we've spent a good chunk of the effort on the project so far, ensuring we are talking about the same thing along the gradient that we have here in the southeast. Secondly, we're looking at not just salt marshes, but some of the surrounding marshes, the brackish and transitional marshes. We'd like to be able to map those distinctive entities too, and even shrub-scrub zones, and particularly Phragmites, which we've had in some abundance in North Carolina, and is also sporadic in a few other places to our south and north, and all over the place, really. The focus will be integrating the field in super high resolution airborne, even UAVs at some point, to collect field data for both training the remote sensing and for assessing the accuracy of it. And then when we have improved vegetation mapping and improved LiDAR, we can do much more improved marsh sea level rise vulnerability assessment. So the institutions here, we've kind of carved this out. On the map on the right is the focus of our study area domain. Within each state, we have differentiating sizes of extents. In North Carolina, we're focused on the outer Pamlico Sound, Albemarle Sound area, Alligator River in particular. In South Carolina, we're focusing on the Baruch Marine Institute's extensive studies at North Inlet, Winyah Bay, the National Estuarine Research Reserve, and in Georgia down at Skidaway Island, but also it's extending down into Sapelo, sort of areas south of Savannah. Along the institutional lines, up front, and most of today is an update on the remote sensing side of this, and that's led by myself and J.P. at ECU. I would say it's the course scale. We took some opportunities here early on to take advantage of the new Landsat, and I'll kind of give you some highlights of that. We have within each of these areas intensive study areas where there is ultra high resolution field-based data collected, but past and ongoing, and then that basically gives us kind of automatic test beds for proving the approaches that we're trying. Skidaway, in particular, has developed with some other folks Diem correction algorithms. So taking LiDAR and improving the estimation of the actual surface elevation, and then applying corrections through statistical means to the raw LiDAR data, and then interpolating the surfaces. And then finally, Jim Morris and the USC folks have worked a lot on the tidal elevation and carbon production and sensitivities there of various salt marshes. And so that's kind of the way we tie it all in together. It feeds in leading up to that. With marsh mapping, central problem has kind of been the diversity of sources. And it's at least in North Carolina of late, we didn't have NWI updated between 1982 and 2010. And the actual definitions of some classes changed. The emergent marshes also did not recognize Phragmites as a distinct class, and that has been somewhat of a holy grail for remote sensing to try to accurately map Phragmites, but there's been a lot of great advances with new sensors and algorithms lately. In addition, he has CCAP, NOAA's Coastal Change Analysis Program. That was traditionally been Landsat-based, highly successful, but it's very broad and oriented toward land use, land cover. With marshes, there's not a lot of classification specificity, so there's no high and low marsh. And there are also some limitations of the accuracy of the classes that it does have. So there is some inherent confusion in mixed pixels with the older Landsat thematic mapper. So that's mostly Landsat 5 and 7. The NEARs have their classification schemes that have been using at fine scale quite successfully. Most of those that I have examined have a limited differentiation of low and high marsh. And then finally, you have looking at sea level rise, the sea level affecting marshes model, or SLAM, that crosswalks NWI, and you could use some of these other classification sources to run a model predicting wetland responses to sea level rise. So we would like to be able to provide some update for models such as SLAM or others, such as the Marsh Equilibrium Model, or MEM. The LiDAR is a serious limiting factor to a degree, even as much as it is revolutionary and improvement for floodplain mapping and so on. With salt marshes, it's rather notoriously variable in accuracy. So to tackle a project with the scope that we have on the southeast has been quite a learning experience. We've leaned heavily on data that the Coastal Services Center has acquired and stitched together, but even there we've had some major gaps to fill, and I'll be walking you through some of that. And we still have ongoing corrections to make. Landsat 8 appeared on the scene last spring with phenomenally new improvements in radiometric resolution. So much of the approach here and the purpose would probably never have been attempted, certainly not successfully concluded with prior Landsat sensors. So we were going to be using Landsat 8 in conjunction with other sensors and applying what's called an object-oriented image analysis technique. So hopefully I don't lose you. Stay tuned. The next bullet we'll cover is field and site scale mapping, and then our vulnerability analysis. So here's just a snapshot of some of these other various marsh classification schemes. This is Landsat-derived CCAP from NOAA, 30 meter spatial resolution, but there the magenta color is all salt marshes. And so you see very little differentiation there. There's been updates to that, and this map is actually from the NEARS down in North Inlet, and they have, kind of the same issue with a little bit of lack of differentiation if you're wanting to separate high and low marsh. So that's the sort of dark teal color in the salt marsh class. Again, not pointing fingers, but that's just the state of what the data could provide in the past. Here's another NEARS classification. This one goes a fairly good step further. I believe this one is aerial image processing, and it does differentiate the wide Spartina alternate flora marshes, but also mud flats here. And that's North Inlet again. Here's a look at NWI coming up. There's a little snapshot from our coastal atlas, and there's an NWI overlay. So you can see the NWI has its limitations. There's basically a large E2EM1N, if you're familiar with NWI. You can look that up. It's an emergent salt marsh that's regularly flooded. And then there's another E2EM1P, which is less or irregularly flooded. So you're differentiating your marshes by a frequency of flooding. That's good, but it doesn't differentiate them in terms of their habitat condition. So what we've got the potential to do is separate the marshes by species. Spartina, tall and low form, Juncus, Phragmites, so forth. Baruch and North Inlet. Here's some little background on that site. We've had to spend a lot of time learning from each other, and to develop training sites and classification approach. So here at the top on the left is an aerial view of the Wacomile River, and to the south this flows through, does a big turn, and then you have the salt marsh. I've got a little animation that shows fresh water coming through and a limited amount of salt flushing through the tidal action. But just to the east of the Baruch area, there's the bay there, and you've got much a stronger tidal action and salt. So there's an immediate separation there between Spartina and Juncus based on the salinity. To the right is elevation from a special data collection that was flown for Baruch and the near, but there's a curious square in the middle, and we're working on trying to find that data. It's kind of in a critical area that the LiDAR have gone missing. This is a aerial view of that region, and just to sort of look at the species kind of zonation. Very wet, very low marshes in this area. Tall and short form Spartina blending up to Juncus and Spartina patens on the marsh kind of fringes. And then you've got, outside of this particular view, more in the fresh, brackish kind of zone, you get into the Phragmites, Sinusoides, Typha, and so forth. So a little bit about the Landsat data we're using, and I'll give you some snapshots. This Landsat's been up since 1972, and it's had a thematic mapper since about 1984 at 30-meter spatial resolution. The new sensor is called the Data Continuity Mission, and Landsat 8, for shorthand, is both a cooperative project of NASA and USGS. They've want to continue the observation of this. It's got vastly improved, like orders of magnitude improved radiometric performance. That means it can collect remote sensing data in much finer precision. That's what we're going to be looking at exploiting. It also collects many more images per day. Even though it retains the 30-meter spatial resolution on the ground, we've got a much greater richness of data to use. So then we can collect imagery through multiple times of the year. You can look at the spectral changes or the phenology of vegetation, and that can actually help you separate species. Here's just a screenshot from a project up on the Great Lakes where they showcase this changes and improvements in the radiometric resolution, increasing toward the bottom. The particular path and rows that we're using, so this is our study area extent in total, and these are just snapshots of the Landsat swaths. It's about 6 different images that are in total being used, or 6 scenes, but there are also different dates involved. We calibrated those data so we have them from even this summer now. In North Carolina, I want to give you a sample of that. This is the Pamlico Sound, Croatan Sound. You have the Coastal Studies Institute, Point Peter Road on the Alligator River. Note that just within a mile or two of the Oregon Inlet there, you become increasingly brackish with distance away. So there's not a lot of great tidal regime here whatsoever. Zooming into those areas with the visible wavelengths, you're going to be able to detect some gradation in the marsh. There's largely Phragmites and Sinusoides over here in Point Peter Road, and then there's mostly primarily Juncus and some fringing Spartina and rack also here at CSI. I'll just change that to a multi-band composite. This imagery, these scenes show middle infrared, near infrared, and visible together, and it adds for just a lot more dramatic differentiation. So we're going to use the image processing to help us with those classifications. In the past, or even currently with the systems such as the Coastal Change Analysis Program, image classification has been pixel-based. So we're going to move into the newer approach of object-oriented image analysis, which is polygon-based. And we're going to basically carve up scenes into homogeneous pixels or patches, and then we're going to classify the patches based on their reflectance. But in addition to that, we're going to be able to feed these classification algorithms more data. So essentially, we'll stack LiDAR DEMs with air photos and even synthetic aperture radar imagery from other satellites into a much richer data stack and then classify these patches. An example of this is a pilot study I did a year ago with at the Rachel Carson NIRS in North Carolina, near Beaufort. And so we put a stack together of LiDAR DEM, orthophoto, including color infrared, and we also had a number of synthetic aperture radar images. There's a huge remote sensing literature on applying SAR imagery. For one thing, it penetrates the clouds. It's an active sensor, kind of all-weather sensor, so it's awesome for emergency management. But for other reasons, or rapid change detection, but for our purposes, it's sensitive to water level. It's sensitive to the vertical structure of vegetation, which varies quite a lot in some marshes. It's sensitive to soil moisture and the biomass content. So we found that in the Rachel Carson pilot study, it was a tremendous improvement when we stacked SAR imagery into the data alongside our DEMs and orthophotos and Landsat imagery. The first product of this Obaya technique is this kind of patchwork quilt of polygons, and this is just a zoomed in sample, thousands upon thousands of polygons instead of pixels. Each of these then gets statistically summarized in terms of those variables I was telling you about, and then they get classified, and we can use some really advanced classification tools, such as classification regression trees, or even neural networks, kind of artificial intelligence algorithms. This is the output of that pilot study, was a map for the NIRS, and I think North Carolina Sea Grant helped support this as well for a student fellowship. But it's just a fine scale resolution image that would take months or certainly weeks to possibly hand digitize. We had really high accuracy on this. Without reporting on the details of that, it was on the order of 95%, which for marshes and intertidal wetlands generally is a kind of phenomenally high accuracy to achieve. And here's some zoomed in looks at that. You might even see some patterns in this that when I overlay the classification on top of it, that there are clearly other classes there, like seagrasses, that we did not actually have a class to represent them. So it's more powerful tool than I'm just amazed with it. There's a summary of that. So coming out of that project, we have high confidence that we could do this for the SALCC project, even with coarser data like Landsat, given the high resolution of the reflectance. The questions remote sensing folks are wanting to ask is, can we apply the same rules or the same decision algorithms for classification to these three areas? And that is an open question right now. For example, we can't apply a rule that differentiates high and low marsh by elevation if we have different elevations different for those marshes in Georgia versus North Carolina, and we most certainly do. Here's where we're at with this. Here's just a preliminary result from classifying the Landsat imagery by itself in the North Inlet, and we have a pretty strong differentiation between the Spartina marsh, that's the kind of dark grayish teal color. We have mudflats popping up in the red. We have tall growth form Spartina in this sort of orange color. We have Juncus and Borichia, and then we have Phragmites and Sinosauroides. So we're still working on trying to maybe see if we can pull frag out from Sinosauroides as we layer in more data. We'll see how lucky we are doing that. JP just walked in. Just perfect timing. I'm going to put the speaker on and let him take it from here.
Yeah. All right. Thanks. Good to see or talk to everybody. Sorry I was a little late. I had a long meeting. So as far as field studies go, basically at this point, most of our field has really focused on getting a feel for the breadth of environments across the system. So in particular, but before I go what we've done, I guess I'll just mention why we're doing it. So first, an obvious point is that we need to be able to calibrate the classification that Tom's just described. And so we are needing sort of sites that we are confident with what they are so that we can use those when we sort of test or train the model. Then, of course, after that process, we certainly need to validate the performance of the model, and so we need to have a separate set of locations that we can then use to sort of validate performance. Of course, we also just are inherently interested in understanding the processes that are affecting or controlling the wetland vegetation that we're seeing, as well as the changes that are going on across the system. So as far as what we are doing or have done, so I'll just kind of go through a variety of things that we've done. Obviously, when we go out in the field, one of our primary goals at this point has been pretty much photography and getting a feel for, qualitatively for vegetation changes. Doing visual IDs, recording in a notebook basically what we see, and so on. We also are combining this work with some RTK GPS studies, which I'll show in a second, where we're using the RTK to basically map elevation at discrete points, and then also using the RTK to map shorelines. We've also combined this with some leaf area index measurements, which Tom has a device that basically looks at light, and from that can get some idea of basically leaf area or sort of a canopy measurement, and we're trying to relate that to what we see in the marsh. And then additionally, we've got aerial photography. Certainly we have a lot in North Carolina, and we are interested in exploring what we can find for the other sites in South Carolina and Georgia. But these data have been useful for looking at sort of snapshots of conditions at higher resolution and evaluating change. And I'll mention some of that. And then we also are, although it wasn't originally part of our project per se, particularly because of some of the conversations that we had earlier in the week about sedimentation and some of our own interest in understanding marshes and sea level rise, we are sort of combining with this project a plan to actually core and measure sedimentation, grain size characteristics, and organic matter in marshes across the 3 states. So as far as where we've done work, I'll just march through a couple areas with some slides. But in North Carolina, our most intensive work has been done at the Coastal Studies Institute, where our lab is. We also have done work across the Croatan Sound at Alligator River, which is part of the National Wildlife Refuge there. Additionally, we have some field work that's been done in Nags Head Woods. Again, this is sort of part of another effort, but it's another area that we can use for ground truth. And then Tom, in his preliminary work, has studied the area around Beaufort a bit. So I think he spoke about that already. So South Carolina, we kind of just did a field trip this summer, Tom, myself, and I'll show you a couple slides. So we visited various sites around Baruch, and then also we went down to Georgia and visited sites around Skidaway. So shown here is a picture of basically the marsh near CSI looking south. This is obviously it's in winter when the grasses were dormant, but I just wanted to give you a feel for the shoreline and the marsh there. We did a number of studies this winter to get a better idea of a variation in the marsh. Shown here is some data that were collected. Sorry, was there a question? Nope. There's some data that were collected. This is with RTK GPS elevations across the marsh near the Coastal Studies Institute. And I don't want to talk about it much, but what you can see is, like, if you look at the end of the transects away from the water, you can see that we transition into the upland. You see slightly higher elevations, getting up to nearly ½ meter. And then as you see across the marsh, if you look carefully, you can see variations in the marsh character, as well as subtle variations in the elevation. And so this was sort of a first effort to sort of see how well what elevation changes we would measure, and then a nice image to sort of help see how it might impact the quality of the marsh. So at this point, that's just sort of some qualitative observations. Here's another marsh just north of CSI near the Visitor Center, where we also conducted similar elevation mapping. At the same time, we also took photographs and did have been doing some sedimentation studies in these areas. So shown here is, again, similar data of elevation across. Again, you can see the upland. You can see some higher areas along the shoreline. And you can see these sort of depressional areas where you can see variation or sort of changes in the marsh character. So now I'm going to go across the Croatan Sound to, this is a picture taken in winter at Point Peter Road, and you can see we're at the very end. This is an interesting location, and again, part of the national, the Alligator River National Wildlife Refuge. And this site in particular is a really high erosion rate area, and in fact, you can see just off in the water a bunch of PVC. That's where the Nature Conservancy has installed some oyster reefs with sort of a test project to sort of see how they can mitigate against shoreline erosion. But again, we are also using this for a site for looking at the Landsat classification efforts. Here's some data that we collected in June of 2014, and this includes the shoreline in green was RTK corrected, and so that was again just this June. The yellow are RTK elevation dots. I don't have them colored as elevation, but those are where several transects were completed to look at basically the type of marsh as well as the elevation and leaf area index. And then offshore was some just single beam bathymetric mapping that we were doing, looking at the bathymetry offshore as an additional effort. In this next slide, you can see this again, the same area, Point Peter Road, and there's a scale up in the upper right. That green shoreline is the same shoreline that I just showed you in the previous image. And what you can see is the dramatic erosion that's going on. And also, if you look carefully in the background of the image, you can see there's been some interesting changes in the marsh. I didn't point it out in the earlier image, but you may have noticed that there was frag along the shoreline. This Point Peter Road site is really going through a lot of changes, both because of shoreline erosion and because of storm surges that have occurred over the last couple decades. And so this is an interesting site and one that we'll use for some more ground truth and validation work. Then in this summer, Tom and I, again, as I said, went on this sort of initial field trip to sort of look at some sites in South Carolina and Georgia. We went to Baruch and had the chance there to meet the director and did some exploring with James Edwards. Here we are discussing on the map places to go. I'm just going to flip through a couple pictures of some of the sites that we visited to just get a feel for places that we could use, again, for calibration or validation. So this is just looking near Baruch, where you can see some juncus and in a transition zone to upland, as well as some spartina. I'll move to another area where you can see more of a platform, juncus marsh, along a road where it's basically right against the roadway. Then another area here where we've got a juncus along the fringe of the upland, and then a spartina, more expansive spartina marsh. Again, I realize without actually seeing a locator map or seeing where this is in Tom's classification, these pictures probably don't mean that much to you. Okay, so I guess you saw some of this when Tom went over it, but anyway, I just wanted to get a feel for at least some of the efforts that have gone on. I should say that many of these photos are actually geo-tagged as well, so we can bring them into obviously our ARC maps and then see where they are in case, we've logged them as well, but some additional effort. Again, here's another site. This is just the opposite side of the picture that I just took, and you can see a little bit more Juncus and some Spartina. And then here is a site, another one just kind of northwest of Baruch, where you're kind of by a bridge going over to another area, and you can see a really extensive frag and Spartina along the shore. So anyway, again, just to give you a feel for some of the sites in South Carolina, again, another transition zone of Marsh. So here's Skeet away. We did similar things. Again, this was really just, exploring. We met with Clark and Mike Robinson, Clark Alexander, co-PI, and took a while there and explored a number of sites. And but I won't go through all those now. So,
and these are some slides from Clark. Basically, building off some of the work that he's done is largely in mapping the marshes down there. He's also been mapping with RTK GPS and doing fine resolution RTK grids almost, and then doing Diem correction with that in addition to some other colleagues. So they built an amazing digital model of this particular marsh, Groves Creek, showing that here. So that's really very helpful to detecting boundaries between tall and short form Spartina and Juncus and other areas. They've applied that to their marshes. It can help the classification, but it also is really powerful when you look at projecting the marsh vulnerability in the future.
Yeah, well, actually, one of the points about that, I just want to go back. You've all probably seen DMs now, and so this might not look all that impressive. But what you might not appreciate is that this DM is a bit different than your typical LiDAR collected DM, which when you fly things from a plane, there's error associated with positioning and so on. This is a field-based correction collected effort. So someone manually went out and digitized and collected GPS points at sites all throughout this marsh. So the power of this DM versus a LiDAR, or actually have this, we can compare it to the LiDAR. Clark's already done some of this, but we're interested in really seeing how, when we actually have a ground-based measurement, how this compares to what we typically get, which is LiDAR-based estimates.
And these are some graphics that show just the correction process that they've gone through. Vladeck and Albert down in Georgia and Georgia Southern have done a lot of that work as well. We want to expand off of that as we integrate the field data we collect, J.P. describing in North Carolina. We're going to do LiDAR corrections up here, and we have amazing new LiDAR being delivered this winter from Hurricane Sandy funded project for a good part of the state. This is showing you the problem that LiDAR does have. It's a well-known issue, and it's very difficult to get around it without doing some sort of post-collection correction.
One of the points, or one of the problems with the Groves Creek area is that while it's a really cool site and they have this amazing data set, vegetation-wise, it's basically all Spartina, and so as much as we wanted to use it for sort of the efforts of this project, it's sort of limiting. So what we kind of are thinking about is that sort of a more localized scale in several other sites, doing sort of following the methodology and looking at LiDAR versus ground-based measurements.
Another example was recently reported on from the remote sensing standpoint using hyperspectral imagery, but which is phenomenal data, multiple spectral bands, but its availability is extremely limited. So we basically been monitoring similar research like this. You can look at the classification details that are coming out in that, down to the species level. Also, quite excellent accuracy going along with those. But we're going to be pushing the envelope with the Landsat and the other sensors that we have available. Where this goes, a lot of the work that Jim Morris at South Carolina has been doing with his marsh equilibrium model, and also looking at basically the hypsometry of marshes, or how much of what area of a marsh is at what elevation. So it's basically these histograms are kind of aerial and elevational related graphs, and they could show whether marshes are kind of evenly distributed across elevation between mean sea level and mean high water, or they're skewed one way or the other. If marshes, as in graph C at the right, are skewed toward the low end, they're going to be quite vulnerable. One of the problems with that this approach has found is both the elevation accuracy and the vegetation specificity. So our project is tackling both the sides of that issue, starting at first with the vegetation. And I just have a little overlay here of what we might be able to do is going beyond using NWI for these types of analyses, actually pulling out the marsh classifications that we do and looking at their elevational ranges distribution. We'll be able to synthesize that aspect, and that will be it'll help future forecasting of marshes. There's another thing that this whole project opens up, and I just want to end with this, but it's JP described the flux that's happening. Even with my periodic visits to the coast, I'm just amazed, and it's a somewhat disturbingly shifting mosaic, and that really calls into question trying to map changes with what's called a post-classification change detection, where you overlay changes. So there are opportunities this project is sort of setting groundwork for, where we can evaluate the changes in marshes on a continuous basis in terms of the marsh health or the vigor, in terms of things like the leaf area, the biomass of the marshes. So I'm really optimistic about those. And I've just got a screenshot here of an example where we've computed 3 indices of marsh condition with the Landsat 8 image. This is North Inlet again, and this is 3 bands essentially that are linear derivatives of the Landsat imagery. Blue is, or the red is a water index, an index of moisture, and the salt marsh there comes in the like pinkish to magenta, the Ina. The vegetation index, NDVI, is showing up in green. So that's really keying in on the areas to the north and west, which are primarily Phragmites, Sinusoidales, very tall, dense growth form, brackish kind of marshes. And then the NDSI is shown in shades of blue primarily, is an index of marsh or mud flats, sediment, and could be rack components in that, basically detritus. And that's keying in this particular instance mainly on the juncus and mud flat content. We're interested in deriving continuous measures from the research product as well from this. I think we kind of stop there for lack of more time, and hope you have some comments and questions.
Thank you so much, Tom and JP. That was great. I'm kind of amazed that y'all can identify species from remote sensing. We do have time for a couple questions, if anyone wants to share them.
Mute off. Hello?
Hello?
Yeah, Mike Harris here. What's the final deliverable from your project? Will it be a series of maps, or what's the ultimate product that you talked about a lot of different studies, some of your own and some of other similar work, but I'm just curious what your product back to the LCC will be.
Yeah, the definite product is the maps of the high and low marsh and as many other components of those as possible. So we will probably deliver those in more than one format, certainly raster image, but since we're taking this object-oriented approach, we may just be able to do that in a little more fine scale, like shape files
Will that be for the 3 study areas or for the entire geography of the LCC?
Well, for the 3 study areas, I would say most certainly, and the entire geography is possible, but we have to kind of see what our quality looks like. And the thing I was mentioning about the accuracy is a concern. If we've only ground truth areas within 3 study areas, I kind of have some hesitation about being able to do the full Southeast geography. But we do have the full Southeast in terms of subsets and our actual classifications. We will be doing these full Landsat scenes that I showed you.
And we did try. I mean, we've mentioned the 3 sites, but as you can see, even North Carolina, there were really 3. And even when we did our skidaway and our Baruch visits, those were really a smattering of sites, and we were looking as we drove between areas. So I mean, there might be some. Yeah, I think our aspiration was the whole area, but I think we'll probably have better verification at in the local areas.
Yeah, there's another example. I'll just click this little extra bonus slide that I had in here. Quite a parallel project that Michigan Tech was doing with these similar type of remote sensing techniques. They especially targeted Phragmites. And now they actually had a GIS kind of predictive model, but before that resulted, they had a map of Phragmites. And that's a pretty vast geography right there. They tested some of these same questions about portability of like the signatures from one area to the next. But I'm pretty conservative about our situation, especially from our initial field visits, because of the range of salinity, tidal range, the marshes on the tidal frame from these areas. So we may only be able to really have full Southeast coverage for particular parts of the classification. But so far, it's looking very, very promising. I showed you that one preliminary map.
We've got a question on the chat box. Can you talk about how you're funded and how you might partner to extend your approach to other areas like the National Estuarine Research Reserves?
Yeah, right now the SALCC is funding this particular kind of the remote sensing centric portion of this, and JP described basically how we leverage as much as possible a lot of other work. I have had some help from Z Grant that they funded a fellowship that did the object-oriented analysis, and that was actually, I think, jointly funded by one of the NEARs down here, North Carolina NEAR. So if
we also there's a project that just ended, but so Clark Alexander was involved in Governor South Atlantic Alliance project across North Carolina, South Carolina, Georgia, Florida. And so in that project, we were looking at estuarine, particularly estuarine shoreline change. But in that effort, we collected a variety of data, and I think we were hoping to leverage some of that to help inform changes that we see in this effort. So, and there are a couple other smaller projects in North Carolina that's, like, for example, on that one figure I showed you where we have a nature conservancy project offshore, and so that's helping us collect data onshore as well. So anyway, there's certainly some leveraging going on, but as far as going to more areas, I don't know that we've identified any specific, plan for expanding areas.
Yeah, I think like some of our imagery covers other areas, and so there are other near sites actually in this geography that we would probably give extra attention to, and So folks like interested in that should, you know, be squeaky wheel.
Well, and Clark's in the near, so some of his efforts.
Yeah, and the Altair site, I think we're working with them. They have a lot of data that's helpful.
But that's a great point. Definitely something we need to do, and we'll certainly strive to do.
JP, there's another question that someone posed. I don't know if we're getting comments that not everyone might see. Yeah, as far as a model for the NEARS mapping, it could be. The other one is the like Fish and Wildlife Service invasive species monitoring. I think there's Park Service habitat monitoring folks. They may be able to use these techniques or adapt them. Certainly the remote sensing software, the modeling that I use is widely and commercially available. And if we publish these, we would want to publish the full protocol, maybe aspects of the rule sets that we use could be handed off.
So one question was about Surgo. Could our data, our sedimentation data, be fed into the soil Surgo data? I mean, our data that we're going to collect in soil is going to be really localized, and it's really would probably focus more on sedimentation rates. So I'm not. Surgo is certainly a valuable product that certainly could be improved, but I don't think we'll integrate it. I mean, it's possible, but yeah.
And Sandra asked about using these techniques at high resolution. Well, that's actually where a lot of those techniques were born, with like orthophotography, and so we're actually kind of going opposite in a way, applying them at coarser resolution. But even in these areas, ours down to about 1 meter resolution imagery, and LiDAR was about 2 meters, and the SAR imagery that I used was about 6 meters. So in that instance, what I did was resampled everything to 6 meter pixel. That makes you follow me.
Yeah, and I guess Bill asked about the NEARS mapping, tying this to the NEARS mapping. Again, I think we sort of addressed that. We aren't directly, at least Tom and I aren't directly working with the NEARS project, but Clark is, and we haven't specifically discussed that, although certainly the data might be useful from that standpoint.
Well,
hey, Tom and JP, this is Brad. Thanks for doing the talk today. I have one question for you about the LiDAR, and that is how important is it to correct the LiDAR? Because it seems like a circular argument if you need to know the vegetation composition to do the correction.
Yeah, that's the thing. You could call it that. I guess if I took uncorrected LiDAR and I put it into the image processing stack and I classify it, if it produces a more accurate user map, it's the end justifies the means. Now then, if you take that map and you want to do something else with it, like the vulnerability assessment, then you have the problem you mentioned. I don't think it's circular logic, but you need the corrected DEMs to do a better vulnerability assessment for the elevation. That goes for SLAM or any other kind of model.
Yeah, but how important is the corrected LiDAR to the vegetation classification?
It remains to be seen. We're not using it extensively everywhere. At a fine scale, I think it's probably more important. At our Landsat scale, it's not really going to be that relevant.
But that brings up, I mean, it's a good question, and I think that's one of the goals of our project was sort of evaluate that. I don't think we have done that fully yet, but that's a very good question.
Yeah.
Well, thanks for the great discussion, everyone. I hate to cut it off, but I have about 1 minute to give just a few quick updates. on behalf of the South Atlantic. I'm sure Tom and J.P. would be willing to answer questions after the fact. Just a few quick things. Louise and I are here. Our door is open if you want to get in touch, if you need support using the Conservation Blueprint. I wanted to announce that the Brown Bag is back, our monthly Triangle Climate and Landscape Researchers Brown Bag. That's held the second Thursday of each month from 12 to 1:30 p.m. We're sort of re-releasing it with a new rotating host schedule that shares between the State Climate Office in North Carolina, the Southeast Climate Science Center, and the Southeast Regional Climate Hub, and then us at the South Atlantic LCC. So we hope this will bring a more diverse range of speakers and local involvement, which we're very excited about. So the next Brown Bag is going to be in October. That's October 9th. And I also wanted to share a quick update on behalf of our partners at the Francis Marion National Forest. They're hard at work on their plan revision and are holding a public meeting next Tuesday, this upcoming Tuesday, September 23rd in North Charleston from 9 a.m. to 2 p.m. So if you want to get involved in shaping the future of that plan, that's a great opportunity. This is next month's web forum. It'll be run by South Atlantic's Rua Mordecai, our lovely science coordinator. So he'll be talking about dealing with sea level rise in Blueprint 2.0. So it's 11 o'clock, and that's it from us. If anyone has any quick questions, I don't mind staying to answer them.
Thanks for the opportunity.
Really appreciate it. Well, thanks, everyone. Have a great rest of your week.